Good morning. Today we'll be discussing about the sources of water and the physical characteristics of water. The sources of water, the surface and subsurface water sources will be discussed by me, Pallavi, and Kartu. And the physical characteristics of water will be discussed by my teammates Aparna, Roshni, and Devika. Here we have a schematic diagram of a typical water supply scheme. The sources of water is divided into the surface and subsurface sources. I'll be discussing about the surface sources. As we all know, ponds, lake, rivers, all those things that we can see on the surface of the earth is termed as the surface sources. And the water collected by all these sources will be transferred into a treatment plant in which it will be going through many steps, and after that this treated water will be distributed to the consumers through the distribution system. Now we'll see the surface water sources. We know which all are these surface water sources: rivers, lake, etc. Now these will get replenished by precipitations like rain, snowfall, etc. And it is getting lost through evaporation, evapotranspiration, subsurface seepage, etc. We know about all these things. We already studied about these things in the previous semesters. Now, the total amount of surface water is usually calculated by taking the total amount of water that is being collected in the catchment area or the watershed area. Many factors affect this total amount of surface water. We'll see which all are those factors. These reservoirs, their storage capacity, and the soil beneath these storage bodies, these the permeability of that soil, the runoff characteristics of this particular land, then the timing of precipitation and the evaporation rate in that particular area. These all are some of the factors that affecting the total amount of surface water. Nowadays, the main factor that affect or making an impact on these factors are the human activities. These affect a huge impact on these factors. It is both positive and negative. So now we'll discuss about the subsurface sources of water, and that will be discussed by Katu. So thank you.
Thank you, Pallavi. And next one is the subsurface water sources. So, the water which gets stored in the groundwater reservoir through infiltration is known as subsurface water. So, we are using underground water for household purposes. Let us see what are the various underground sources. First one is the springs. So, springs are the ones which the groundwater is brought to the surface by some natural means, that is known as spring water. Next one is the wells. Wells are further classified as artesian wells, dug wells, driven wells, and tube wells. Tube wells are of two types: shallow tube wells and deep tube wells. Next one is the infiltration wells and infiltration gallery. So, the groundwater is damped by artificial means by constructing the infiltration wells and infiltration galleries. And also, subsurface water is generally pure due to the filtration during percolation. And also, these are less affected by the bacteria. But the demerits of subsurface water is it is rich in dissolved salts, minerals, and gases. So, the next topic, that is physical properties of water, will be continued by Aparna. Thank you.
Thank you, Kartu. I'm Aparna Srinivas. Now, the next topic is physical characteristics of water and its subsections, that is turbidity, taste and odor, temperature, color, and specific conductivity. I'll be explaining turbidity. Taste and odor and temperature will be explained by Roshni, and then color and specific conductivity by Devika. So, turbidity. Turbidity is a measure of degree to which the water loses its transparency due to the presence of suspended particles. That can be either inorganic matters like clay, silt, etc., or the bacteria, algae, fungi, such microorganisms. So as suspended solids in water increases, turbidity also increases, and the turbidity can be expressed in milligrams per liter or ppm, and which is the amount of suspended particles. So 1 milligrams per liter is 1 milligram of finely divided silica in 1 liter of distilled water, and the permissible limit is 5 to 10 ppm. So next one is the turbidity meter. So the common method of measuring turbidity of water, first one is turbidity rod, Jackson's turbidity meter, then Baylis turbidity meter, and nephelometer. So first one, turbidity rod, that is used in field, and it contains the graduated aluminum rod, a graduated tape, then a position of eye at the top of graduated tape, and at the lower part of the aluminum rod it contains a platinum needle, and then nickel ring is attached. And here, to find the turbidity rod is immersed in water, and I is kept constant at the marked position, and the rod is moved slowly in water till the platinum needle get disappeared, and the turbidity is the reading at the water surface in ppm. So Jackson's turbidity meter, here the unit is JTU, and that is measured for turbidity greater than 25 ppm, preferably more than 100 ppm. So that consists of a metal stand on which the metal container is placed, and then the glass tube. So the water sample is poured in the glass tube, and then the image of the flame in the metal stand, within the metal stand, can be a candle or a light bulb. So the flame or the light of the standard candle or the bulb is seen through the turbid water, and the level of the water in the glass tube is gradually increased till the image get disappeared, and the reading on the glass tube against the water surface that gives the turbidity in ppm. So next one is Baylis turbidity meter. Its unit is BTU, and it's a very accurate instrument and preferred for turbidity less than 5. So here a galvanized iron box with 2 glass tubes, in which one of the glass tube contains the standard solution of non-turbidity, and another contains the water sample of unknown turbidity that is to be found out. So a bulb and a reflector is placed in one side and the tubes on the other side. So the tubes is surrounded by the blue cobalt plate, and its bottom by a white opal glass plate, and as the blue cobalt plate is covered, the blue light is cast in both the tube, and the difference, the comparison is made, and the turbidity is measured. The next one is nephelometer. In nephelometer, that gives a very precise measurement and measured for turbidity 0 to 1 ppm, and the unit is NTU. So the basic difference between Baylis turbidity meter and nephelometer is that Baylis turbidity meter, the light was seen or measured passed straight through the turbid water, while in case of nephelometer, the light intensity is measured at right angle to the incident light. So Baylis turbidity meter and Jackson turbidity meter is based on the light absorption principle, whereas in nephelometer it's based on the light scattering principle. So this is all about turbidity, and next I would call upon Roshni. Thank you.
So thank you, Aparna. So I'm Roshni. So now I'll be continuing with the next 2 physical characteristics of water, which is taste and odor and temperature. So first let us discuss about taste and odor. So taste and odor, as you all know, that pure water does not have any particular taste and odor. So they may develop due to natural or artificial reasons. So artificially, it is due to disinfection process like chlorination or presence of compounds like H2S or metallic salts or alkaline impurities. Now, here I'd like to discuss two terms associated with it, which is odor intensity and threshold odor number. Odor intensity is the extent of taste or odor present in a particular sample of water, and threshold odor number is the number of times the sample of water is diluted. For public water supplies, the threshold number should be about 1 and it should not exceed 3. Now, moving on, the next physical characteristic of water, which is temperature. So, temperature, as you all know, is a very important physical factor that determines water quality. So, let us consider an example of a natural water system like a lake or a river. So, what happens when temperature increases? Increase in temperature leads to decrease in the solubility of oxygen in water. Rise in temperature is also associated with increased growth rate of microorganisms. So while they are growing, they consume large amount of dissolved oxygen at a faster rate, and the level of, as a result of which, the level of dissolved oxygen in water will decrease. So this will in turn affect the water quality and hence the aquatic life. Now, temperature also affects disinfection process, because lower the temperature, lower will be the efficiency of the disinfection process. Now, as you can see here, the temperature of the water in streams and rivers varies from 0 to 35 degrees Celsius. For potable water, the temperature that is desirable is about 10 degrees Celsius, and it should not be more than 25 degrees Celsius. So, the next two physical properties of water will be continued by Devika. Thank you.
Good morning, I am Devika Prakash. Now we will discuss about the physical characteristics of water such as color and specific conductance. Color is usually due to the organic substance in colloidal form and also due to the presence of manganese and iron. The color can be measured by comparing the sample with a standard solution using a glass tube called Nessler tube. This standard solution is produced by dissolving 1 milligram of platinum cobalt in 1 liter of distilled water. And for precise determination of color, an instrument called tintometer is used. This tintometer consists of one eyepiece with two holes. A slide of standard solution is observed through one hole and the sample is observed through another hole. Then these two samples are combined until a matching color is obtained, and the color intensity of the sample is that of the matching one. And the unit of color through this tintometer is measured using platinum cobalt scale, and for public supply the number on the cobalt scale should not be less than 10 and the maximum limit should be 20. Next is specific conductance. Specific conductance is also known as electrical conductivity. It is the measure of the transport of electric charge or the measure of the total dissolved solids. This total dissolved solids includes the inorganic salts and small amounts of organic matters present in water. It is calculated by multiplying the specific conductivity and the conductivity factor, which ranges from 0.54 to 0.96. And the unit of specific conductance is Siemens per centimeter. Thank you.